Let's suppose that we're given this graph. We're told this is a polynomial. This is the graph of a polynomial. And we want to find a polynomial that would match up with this graph. In other words, we want to find a mathematical model for this graph. Well, one of the things we could note is the zeros. Notice we can see what they are here, -3, -1, and 1. And we know this, that if those are the zeros, then factors of the polynomial are going to be x minus each one of those. So one factor would be x minus a -3, that's this one, x minus a -1, and x minus 1, which, if we cleaned up these little two negatives back to back, making them a plus, we have x plus 3, x plus 1, x minus 1. Now, the a here, what that's for, what we have now is a polynomial, and it passes through each one of these x-intercepts. That's what this will do. But if I left the a off and I said, well, what is the y-intercept? And you plugged in a 0 here for each of the x, you would find that the y-intercept is -3. Well, what this a is for is to contort this polynomial so that we can force it to pass through this -6. We want to stretch it out. Normally it would cross here if this a was 1, but we want to make it go down here and cross through -6. So what I can do is I can say, okay, I want to make this polynomial pass through the point 0, -6. So I'm going to put a 0 in for each x and a -6 for the p of x. And then just solve for a. And we find that a is equal to 2. I put that in here, and now we have a polynomial that has each of these zeros and this y-intercept. Okay, now let's look at another one. Let's suppose we've got this one. Here's another polynomial, and once again we can see clearly what the zeros are. We've got -1, 1, and 2. But this time, I'm taking note of the fact that this polynomial bounces here. See, it doesn't really cross through the x-axis, it just bounces. So I'm going to say that this polynomial is going to have an even multiplicity. And for simplicity's sake, I'm just going to make it multiplicity 2. I can make it 4 if I wanted to, or 6, as long as it's an even multiplicity. And I want to keep it as simple as possible, so I'll just make it a multiplicity 2. Now, once again, we've got this polynomial. I put a here because I want it to pass through this point 0, 6. I've got x minus a -1, but I'm squaring that, see, because of the multiplicity 2. X minus 1, x minus 2, see? Now, let's clean it up a bit, and here's what we have. Now, I'm going to make the polynomial pass through this point 0, 6. So I'll put a 0 in for the x and a 6 for the p of x. And here's what we've got. So this is like 2a equals 6 or a equals 3. And here's our polynomial. This has the y-intercept of 0, 6 and each of these x-intercepts, and it's going to bounce here at the -1 if you want to try that out and graph it. Okay. Now, let's suppose we're not looking at a graph, we're just given the zeros, and we're told that our polynomial passes through -2, 2. So I just want to come up with a polynomial that has these zeros and passes through the point -2, 2. Well, here we go. We've got x minus a -4, x minus a -1, x minus 3. Cleaning it up gives this. Now this time, we're not making this polynomial pass through a particular y-intercept. We're making it pass through this point -2, -2. So I'm going to put a -2 in for the x and a -2 in for the p of x and solve for a. So here we go. There it is. Now I just, do the arithmetic here. Negative 2 and 4 is 2. Negative 2 and 1 is negative 1. Negative 2 and negative 3, negative 5. Now I just want to solve this. And notice that this over here is going to be a positive 10, right? 10a equals negative 2. If I divide, I get a is equal to negative 1/5, and now I have my polynomial. There it is. This is a polynomial that has these zeros and passes this point, negative 2, negative 2.